Mathematical Principles of Natural Philosophy by Sir Isaac Newton. Book 1 Of the Motion of Bodies. Section 1 Of the methods, the first and last ratios of quantities, by the help whereof we demonstrate the propositions that follow. Lemma 1 Quantities and the ratios of quantities, which in infinite times converge continually to equality, and before the end of that time approach nearer the one to the other than by any given difference, become ultimately equal. If you deny it, suppose them to be ultimately unequal, and let D be their ultimate difference. Therefore, they cannot approach nearer to equality than by that given difference D, which is against the supposition. Lemma 2 If in any figure ACE, terminated by the right lines AE, and the curved ACE, there be inscribed any number of parallelograms AB, BC, CD, and C, comprehended under equal basis AB, BC, CD, and C, and the size BB, CC, DD, and C, parallel to one side AA of the figure, and the parallelograms AKBL, BLCM, CMDN, and C are completed. Then, if the breadth of those parallelograms be supposed to be diminished, and their number to be augmented in infinitum, I say that the ultimate ratios which the inscribed figure AKBLCMDD, the circumscribed figure AALBMCNDOE, and curvilinear figure AABCDE will have to one another and ratios of equality. For the difference of the inscribed and circumscribed figures is the sum of the parallelograms KL, LM, MN, DO, that is, from the equality of all their bases, the rectangle under one of their bases KB, and the sum of their altitudes AA, that is, the rectangle ABLA. But this rectangle, because its breadth AB is supposed diminished in infinitum, becomes less than any given space, and therefore by lemma 1 the figures inscribed and circumscribed before become ultimately equal one to the other, and much more will be intermediated, curvilinear figure be ultimately equal to either QED. Lemma 3 The same ultimate ratios are also ratio of equality. When the breadth AB, BC, DC, and C of the parallelograms are unequal and are all diminished in infinitum, for supposed AF equal to the greatest breadth, and complete the parallelogram FAAF. This parallelogram will be greater than the difference of the inscribed and circumscribed figures, but because its breadth AF is diminished in infinitum, it will become less than any given rectangle QED. Hence, the ultimate sum of those evanescence parallelograms will in all parts coincide with the curvilinear figure. Much more will rectilinear figure comprehended under the chord of evanescence arcs A, B, B, C, C, D, and C ultimately coincides with TLC curving the linear figure, and also the circumscribed rectilinear figure comprehended under the tangent of the same arcs, and therefore this ultimate figure as to their perimeters ACE are not rectilinear but curvilinear limits of rectilinear figures. Lemma 4. If in two figures ACCE, PPRT, you inscribe as before two ranks of parallelograms and equal number in each rank, and when their breadths are diminished in infinitum, the ultimate ratios of the parallelograms in one figure to those in the other, each to each respectively, are the same. I say that those two figures ACCE, PPRT, are to one another in that same ratio. For as the parallelograms in the one and severally to the parallelograms in the other, so by composition, in the sum of all in the one to the sum of all in the other, and so is the one figure to the other, because by the lemma 3, the former figure to the former sum and the later figure to the later sum are both in the ratio of equality, QED. Hence, if two quantities of any kind are anyhow divided into an equal number of parts, and those parts with their number is augmented, and their magnitude diminished in infinitum, have a given ratio, one to the other, the first to the first, the second to the second, and so on in order, the whole quantities will be one to the other in that same given ratio. For if, in the figure of the lemma, the parallelograms are taken one to the other in the ratio of the parts, the sum of the parts will always be as the sum of the parallelograms, and therefore supposing the number of the parallelograms and parts to be augmented, and their magnitudes diminished in infinitum, the sum will be in the ultimate ratio of the parallelogram in the one figure to the corresponding parallelogram in the other. That is, by supposition, in the ultimate ratio of any parts of the one quantities to the corresponding parts of the other. Lemma 5. In similar figure, or source of homogeneous size, whether curvilinear or rectilinear and proportional, and the area are in the duplicated ratio of the homogeneous side. Lemma 6. If any arc ACB given in position in subtended by its chord AB, and in any point A, in the middle of the continued curvature, is touched by the right line AD, produced both ways, then if the points A and B approach one another and meet, I say the angle BAD, contained between the chord and the tangents, will be diminished in infinitum, and ultimately will vanish. For if that angle does not vanish, the arc ACB will contain with the tangent AD an angle equal to the rectilinear angle, and therefore the curvature at the point A will not be continued, which is against the supposition. Lemma 7. The same things being supposed, I say that the ultimate ratio of the arc, chord, and tangent, and one of any other, is the ratio of equality. For while the point B approaches toward the point A, consider always A, B, and AD and produce to be remote points B and D and parallel to the second BD through DB, and let the arc ACB be always similar to the arc ACB. Then supposing to the point A and B to coincide, the angle DAB will vanish by the preceding lemma, and therefore the right lines AB, AD, which should always fit it, and the intermediate arc ACB will coincide and become equal among themselves. Wherefore the right lines AB, AD, and the intermediate arc ACB, which are always proportional to the former, will vanish and ultimately acquire the ratio of equality, QED. 물 마실게요. 어디까지 왔지? Corollary 1. Once if through B we draw BF parallel to the tangents, always cutting by right line AF passing through A in F, this line BF will be ultimately in the ratio of equality with the Evanson's arc ACB, because completing the parallelogram AFBD, it is always in the ratio of equality with AD. Corollary 2. And if through B and A more right lines are drawn as BE, BD, AF, AG, cutting the tangent AD and its parallel BF, the ultimate ratio of all the abscisses AD, AE, BF, BG, and of the chord and the arc AB, any one of any other, any one to any other, will be the ratio of equality. Corollary 3. And therefore in our reasoning about ultimate ratios, we may freely use any one of those lines for any other. Lemma 8. If the right lines AR, BR with the arc ACB, the chord AB, and the tangent AD constitute three triangles, RAB, RACB, RAD, and the points A and B approach and meet, I say that the ultimate form of these evanescent triangles is that of similitude, and their ultimate ratio that of equality. For while the point B approaches toward the point A, consider always AB, AD, AR, and produce it to the remote point BD and R, and RBD as drawn parallel to RD. And let the arc ACB be always similar to the arc ACB. Then supposing the point A and B to coincide, the angle BAD will vanish, and therefore the three triangles RAB, RACB, RAD, which are always finite, will coincide, and on that account become both similar and equal. And therefore the triangles RAB, RACB, RAD, which are always similar and proportional to these, will ultimately become both similar and equal among themselves, QED. Corollary, and hence in all reasoning about ultimate ratios, We have indifferently used any one of those triangles for any other. Lemma 9. If a right line AE and the curved line ABC, both given by position, cut each other in a given angle A, and to that right line in another given angle BDCE, and ordinately applied, meeting the curve in B, C, and the points B and C together approach toward and meet in the point A. I say that the areas of the triangle ABDACE will ultimately be one to the other in the duplicate ratios of the size. For while the points B, C approach toward the point A, suppose always AD to be produced to the remote points D and E, so as ADAE may be proportional to ADAE, and the ordinated DBEC to be drawn parallel to the ordinates DB and EC, and meeting AB and AC produce it in B and C. Let the curve ABC be similar to the curve ABC, and draw the right line AG so as to touch both curve in A, and cut the ordinated DBEC, DBEC in FG. Then, supposing two lengths AE to remain the same, let the points B and C meet in the point A, and the angle CAG vanishing the curvilinear areas ABD, ACE will coincide with the rectilinear areas AFD, AGE, and therefore by lemma 5 will be one to the other in the duplicate ratios of the size AD, AE, but the areas ABD, ACE are always proportional to the areas, and so the size AD, AE are to this size, and therefore the areas ABD, ACE are ultimately one to the other in the duplicate ratios of the size AD, AE, QED. Lemma 10. The spaces which a body described by an infinite force urging it, whether that force is determined and immutable, or is continually augmented or continually diminished, are in the very beginning of the motion, one of the other in the duplicate ratio of times. Let the times be represented by the line AD, AE, and the velocities generated in those times by the ordinated DBEC. The spaces described with these velocities will be as the areas ABD, ACE, described by those ordinates, that is, at the very beginning of the motion, by lemma 9, in the duplicated ratio of the time AD, AE, QED. Corollary 1. And hence, one may easily infer, that is, the average of bodies describing similar parts of similar figures in proportional times are nearly as the squares of the times in which they are generated. If so, if these errors are generated by any equal forces similarly applied to the bodies and measured by the distances of the bodies from those places of the similar figures, at which, without the action of those forces, the bodies should have arrived in those proportional times, Corollary 2. Both the errors and that are generated by proportional forces similarly apply to the bodies that similar parts of the similar figures, or as the forces and the squares of the time conjunctly. Corollary 3. The same things is to be understood of any spaces whatsoever described by bodies urged with different forces, all which in the very beginning of the motion are as the forces and the squares of the time conjunctly. Corollary 4. And therefore the forces are the spaces described in the very beginning of the motion directly, and the squares of the time is inversely. Corollary 5. And the squares of the times are as the spaces described directly and the forces inversely. Scholium. If in comparing intermediately quantities of different sorts, one with another, anyone is said to be as any other directly or inversely. The meaning is that the former is augmented or diminished in the same ratio with the latter or with the reciprocal. And if anyone is said to be as any other two or more directly or inversely, the meaning is that the first is augmented or diminished in the ratio compounded of the ratio in which the others or the reciprocals of the others are augmented or diminished. As if A is said to be B directly and C directly and D inversely, the meaning is that A is augmented or diminished in the same ratio with B cross C cross the reciprocal of D. That is to say that A and BC over D arc one to the other in the given ratio. Lemma 11. The evanescent substance of the angle of contact, inner curves which at the points of contact have the finite curvature, is ultimately in the duplicate ratio of the substance of the conterminate arc. Case 1. Let AB to be arc, AD is tangent, BD the substance of the angle of contact perpendicular on the tangent. AB the substance of the arc. Draw BG perpendicular of the substance AB and AG of the tangent AD, meeting in G. Then let the point D, B, and G approach to the point D, B, and G. And suppose J to be the ultimate intersection of the line BG, AG when the point D, B have come to A. It is evident that the distance GJ may be less than any assignable, but from the nature of the circle passing through the points ABG, ABG, AB square is equal to AG times BD, and AB square is equal to AG cross BD, and therefore the ratio of AB squared to AB square is compounded of the ratio of AG to AG and of BD to BD. But because GJ may be assumed of less length than any assignable, the ratio of AG to AG may be such as to differ from the ratio of equality by less than any assignable difference. And therefore the ratio of AB squared to AB squared may be such as to differ from the ratio of BD to BD by less than any assignable difference. Therefore, by lemma 1, the ultimate ratio of AB squared to AB squared is the same with 이게 PDF 복사본이라서요. 중간중간 글자가 안 나온 데가 있어요. 건너뛰고 읽겠습니다. Ultimate ratio of BD to BD, QED. Case 2. Now let BD be inclined to AD in any given angle, and the ultimate ratio of BD to BD will always be the same as before, and therefore the same with the ratio of AB squared to AB squared, QED. Case 3. And if we suppose the angle D not to be given, but that the right line BD converges to a given point, or when determined by any other condition whatever, nevertheless the angle D being determined by the same law, will always draw nearer to equality and approach nearer to each other than by any assigned differences, and therefore by lemma 1 will at last be equal, and therefore the line BD arc in the same ratio to be other as before, QED. Core value 1. Therefore, since the tangent AD, the arc AB, and their sines BD, BC become ultimately equal to the chord AB, their squares will ultimately become as the subtens BD. Corollary 2. Their squares are also ultimately as the versed sines of the arcs, bisecting the chord and converging to a given point. For those versed sines arc as the subtens BD. Corollary 3. And therefore the versed sine is the duplicate ratio of the time in which a body will describe the arc with a given velocity. Corollary 4. The rectilinear triangles ADB are ultimately in the triplicate ratio of the sides AD, and in a sequiplicate ratio of the sides DB, as being the ratio compounded of the sides AD to DB and of the AD to DB. So also the triangles ABC are ultimately in the triplicate ratio of the sides BC. What I call the sesquiplicate ratio is the subduplicate of the triplicate, as being compounded of the simple and subduplicate ratio. Corollary 5. And because DB are ultimately parallel and in the duplicate ratio of the line AD, the ultimate curvilinear areas ADB will be, by the nature of the parabola, 2/3 of the rectilinear triangles ADB, and the segments AB will be 1/3 of the same triangles, and thence those areas and those segments will be in the triplicate ratio as well of the tangent AD as the chord of an arc AB. Scolium. But we have all along supposed to angle of contact to be neither infinitely greater nor infinitely less than the angles of contact made by circles and their tangents. That is, that the curvature at the point A is neither infinitely small nor infinitely great, or that the interval aj is of finite magnitude. For dB may be taken as a dq, in which case no circle can be drawn through the point A between the tangent AD and the curve AB, and therefore the angle of contact will be infinitely less than those of circle. And by like reasoning, if dB be made successfully 잠시만요. And by your like reasoning, if dB be made successfully as ad to the power 4, ad to the power 5, ad to the 6th, ad to the 7th, and c, we shall have a series of angles of contact proceeding in infinitum, wherein every succeeding term is infinitely less than the preceding. And if dB be made successively and ad square, ad to the power of 3 over 2, ad to the power of 4 over 3, ad to the power of 5 over 4, ad to the power of 6 over 5, ad to the power of 7, and c, we shall have another infinite series of angles of contact, the first of which is of the same sort with those of circle, and the second infinitely greater, and every succeeding one infinitely greater than the preceding. But between any two of these angles, another series of intermediate angles of contact may be interposed, proceeding both ways in infinitum, wherein every succeeding angle shall be infinitely greater of infinitely less than the preceding. As if between the term of ad square and ad cube there will interpose the series of ad to the power of 13 over 2, 11 to the 5, and 9 over 4, and 7 over 8, 5 over 2, 8 over 3, 14 over 11 over 4, 14 over 5, 17 over 6, and c. And again, between any two angles of this series, a new series of intermediate angles may be interposed, differing from one another by infinite intervals, nor is nature confined to other bounds. Those things which have been demonstrated of curved lines, and the supervised which they comprehended, may be easily applied to the curve supervised and content of solids. These lemmas are premised to avoid the tediousness of deducing perplexed demonstrations ad absurdum according to the method of the ancient geometries. For demonstrations are more contracted by the method of indivisible, but because the hypothesis of indivisible seems somewhat harsh, and therefore that method is reckoned less geometrical, I choose rather to reduce the demonstrations of the following propositions to the first and last sums and ratio of nescence and evanescence quantities, that is, to the limits of those sums and ratios, and so to premise as short as I could the demonstrations of those limits. For hereby the same things is performed as by the method of indivisible, and now those principles being demonstrated, we may use them with more safely. Therefore, if hereafter I should happen to consider quantities as made up of particles, or should use a little curved line for right ones, I would not be understood of mean indivisibles, but evanescence divisible quantities, not the sum and ratios of determinate parts, but always the limits of sums and ratios, and that the force of such demonstrations always depends on the method laid down in the foregoing lemmas. Perhaps it may be objected that there is no ultimate proportion of inefficient quantities, because the proportion before the quantities have vanished is not the ultimate, and when they are vanished is none. But by the same argument, it may be alleged that a body arriving at a certain place and their stopping has no ultimate velocity, because the velocity before the body comes to the place is not its ultimate velocity. When it has arrived is none. The answer is easy, for by the ultimate velocity is meant that with which the body is moved, neither before it arrives at its last place and the motion ceases, nor after, but at the very instant it arrives. That is the velocity with which the body arrives at its last place, and with which the motion ceases. And in like manner, by the ultimate ratio of inefficient quantities is to be understood the ratio of quantities, not before they vanish nor afterwards, but with which they vanish. In like manner, the first ratio of nascent quantities is that with which they begin to be, and the first of last sum is that with which they begin and cease to be, or to be augmented or diminished. There is a limit which the velocity at the end of the motion may attain, but not exceed. There is the ultimate velocity, and there is the like limit in all quantities and proportions that begin and cease to be. And since such limits are certain and definite, to determine the same is a problem strictly geometrical. But whatever is geometrical we may be allowed to use in determining and demonstrating any other things that is likewise geometrical. It may also be objected that if the ultimate ratios of inefficient quantities are given, their ultimate magnitudes will be also given, and so all quantities will consist of indivisible, which is contrary to what Euclid has demonstrated concerning incommensurable in the 10th book of his Elements. But this object is founded on the false supposition. For those ultimate ratios with which quantities vanish are not truly the ratios of ultimate quantities, but limit toward which the ratios of quantities decreasing without limit do always converge, and to which they approach nearer than by any given difference, but never go beyond, nor in effects attain till the quantities are diminished in infinitum. This thing will appear more evident in quantities infinitely great, if the quantities those whose difference is given be augmented in infinitum, the ultimate ratio of these quantities will be given, to wit, the ratio of equality. But it does not from thence follow that its ultimate or greater quantities themselves, whose ratio that is will be given. Therefore, if in what follows, for the sake of being more easily understood, I should happen to mention quantities as least, or evanescence, or ultimate, you may not to suppose that quantities of any determinate magnitude and meant, but such as are conceived to be always diminished without end. 섹션 1을 다 읽었고요. 섹션 2까지 읽으면 될 것 같네요. 오늘 읽고 잠깐 떠들다가 갈 것 같아. 길게 떠들진 않을 것 같고. 마저 읽겠습니다. 섹션 2. Of the invention of Centripetal force. Proposition 1, Theorem 1. The areas which revolving bodies described by Ready thrown to be immovable? Center force to lie in the same immovable planes and are proportional to the times in which they are described. For suppose the time to be divided into equal parts, and in the first parts of that time let the body by its innate force describe the right line AB. In the second parts of the time, the same would by law 1, if not hindered, proceed directly to C, all on the line BC equal to AB, so that by the ready AS, BS, CS, drawn to the center the equal areas ASB, BSC would be described. But when the bodies arrive at B, suppose that the centripetal force acts at once with a great impulse, and turning aside the body from the right line BC compels it afterward to continue this motion along the right line BC. Draw CC parallel to BS, meaning BC in C, and at the end of the second part of the time, the body by corollary one of the laws will be found in C, in the same plane with the triangle ASB, join SC, and because SB and CC are parallel, the triangle SBC will be equal to the triangle SBC. And therefore, also to be triangle SAB. By the like argument, if the centripetal force acts successively and in C, D, E, and C, and makes the body in each single particle of time to describe the right lines C, D, D, E, E, F, and C, they will all lie in the same plane, and the triangle SCD will be equal to the triangle SBC, and SDE to SCD, and SEF to SDE. And therefore, in the equal times, equal areas are described in one immovable plane, and by composition, any sums SADS, SAFS of those areas are one to the other as the times in which they are described. Now let the number of those triangles be augmented, and their breadth diminished in infinitum. And by corollary 4 lemma 3, the ultimate perimeter ADF will be curved line, and therefore the centripetal force by which the body is perpetually drawn back from the tangent of the curve will act continually, and any described areas SADS, SAFS which are always proportional to the times of describe will in this case also be proportional to those times, QED. Corollary 1. The velocity of a body attracted towards an immovable center in space void of resistance is reciprocally as the perpendicular let fall from the center on the right line that touches the orbit. For the velocities in those places A, B, C, D, E are as the base A, B, B, C, C, D, D, E, E, F of equal triangles, and these bases are reciprocally as the perpendiculars let fall upon them. Corollary 2. If the chord A, B, B, C of two arcs successively described in equal times by the same body, in spaces void of resistance, are completed into a parallelogram ABCV, and the diagonal BV of this parallelogram in the position which is ultimately acquired when those arcs are diminished in infinitum in produced both ways it will pass through the center of the force. Corollary 3. If the chord A, B, B, C, and D, E, E, F of arc described in equal times in spaces void of resistance are completed into the parallelograms A, B, C, V, D, E, F, C. The force in B and E are one to the other in the ultimate ratio of the diagonal BV, EZ when those arcs are diminished in infinitum. For the motions BC and EF of the body by corollary 1 of the laws are compounded of the motions BC, BV, and EF, EZ. But BV and EZ, which are equal to CZ and FF, in the demonstration of the preposition, were generated by the impulse of the centripetal force in B and E, and are therefore proportional to them those impulses. Corollary 4. The forces by which bodies in spaces void of resistance are drawn back from rectilinear motions and turn into curvilinear orbit are one to another as the verse signs of arc described in equal times, which verse signs tend to be to the center force and bisect the chord when those arcs are diminished to infinity. For such verse sign are the halves of the diagonals mentioned in Corollary 3. Corollary 5. And therefore, those forces are to the force of gravity as the said verse signs to the verse signs perpendicular to the horizon of those parabolic arcs which projectiles describe in the same time. Corollary 6. And the same things do all hold good by Corollary 5 of the laws when the planes in which the bodies are moved together with the centers of force which are placed in those planes are not at rest but move uniformly forward in right lines. Proposition 2, Theorem 2. Every body that moves in any curved line described in the plane, and by a radius drawn to a point either immovable or moving forward with an uniform rectilinear motion, describe about that point's areas proportional to the times is urged by the centripetal force directed to the point. Case 1. For every body that moves in the curved line is by law 1, turned aside from its rectilinear course by the action of the some force that impels it, and the force by which the body is turned off from the rectilinear course and is made to describe in equal times the equal list triangle SAP, SBC, SCD, and C. About the immovable point S. By XL Book 1, Elementary and Law 2. X in the place B according to the direction of the linear parallel to CC, that is in the direction of the line BS, and in the place C according to the direction of the line parallel to DD, that is in the direction of the line CS and C, and therefore X always in the direction of line tending to the immovable point S, QED. Case 2. And by Corollary 5 of the laws, it is indifferent whether the superficies in which a body describe a curvilinear figure be quiescence of moves together with the body the figure describe and the point S uniformly fall in the right lines. Corollary 1. In non-resisting space or mediums, if the areas are not proportional to the times, the forces are not directed to the points in which they already meet, but deviate their form in consequentia or toward the parts to which the motion is directed, if the description of the areas is accelerated but in antecedentia if retarded. Corollary 2. And even in resisting mediums, if the description of the areas is accelerated, the direction of the force deviates from the points in which the ready meets toward the parts of which the motion tends. Scholium. A body may be urged by centripetal force compounded of several forces, in which case the meaning of the proposition is that the force which results of all tends to the point S. But if any force acts perpetually in the direction of lines perpendicular to the described surface, this force will make the body to deviate from the plane of its motion, but will neither augment nor diminish the quantity of described surface and is therefore to be neglected in the composition of forces. Proposition 3, Theorem 3. Every body that by the rays is drawn to the center of another body, howsoever moved, describe areas about that center proportional to the times, is urged by the force compounded out of the centripetal force tending to that other body, and of all the accelerative force by which that other body is impelled. Let L represent the one, and T the other body, and by Corollary 6 of the laws, if body are urged in the direction of parallel lines, by a new force equal and contrary to that by which the second body T is urged, the first body L will go on to describe about the other body T the same areas as before. But the force by which that other body T was urged will be now destroyed by an equal and contrary force, and therefore by law 1. That other body T now left to itself will either rest or move uniformly forward in a right line, and the first body L, impelled by the difference of the forces, that is, by the force remaining, will go on to describe about the other body T areas proportional to the times. And therefore, by theorem 2, the difference of the forces is directed to the other body T as in center, QED. Corollary 1. Hence, if one body L by radius drawn to the other body T describe areas proportional to the times, and from the whole forces by which the first body L is urged, whether the force is simple or according to corollary 2 of the laws, compounded out of several forces, we subduct by the same corollary that whole accelerative force by which the other body is urged. The whole remaining force by which the first body is urged will tend to the another body T as its center. Corollary 2. And if these areas are proportional to the times nearly, the remaining force will tend to the other body T nearly. Corollary 3. And vice versa, if the remaining force tends nearly to the other body T, those areas will be nearly proportional to the times. Corollary 4. If the body L, by a radius drawn to the other body T, describes areas which compared with the times are very unequal, and that other body T be either at rest or moves uniformly forward in a right line, the action of the centripetal force tending to that other body's T is neither known at all, or it is mixed and compounded with very powerful actions of other forces, and the whole force compounded to them all if they are many and directed to others, another immovable or movable center. The same thing is obtained when the other body is moved by any motion whatsoever, provided that centripetal force is taken, which remains after subducting that whole force acting upon that other body T. Scholium. Because the unequal description of areas indicates that the center is respected by the force with which the body is most affected, and by which it is drawn by from its rectilinear motion and retains it in its orbit, why may be not be allowed in the following discourse to use the equalable description of areas as an indication of a center, about which your circular motion is performed in free spaces. Proposition 4, Theorem 4. The centripetal force of bodies which by equable motions describe different circle tend to the center of the same circles, and are one of the other as the squares of the arc described in equal times applied to the radii of the circle. These forces tend to the center of the circle by prop 2 and quality 2, prop 1, and are one to another as the first signs of the list are described in equal times. That is, as the square of the same arcs applied to the diameters of the circle by lemma 7. And therefore, since those arcs are described in any equal times, and the diameters are as the radii, the forces will be as the squares of arc described in the same time applied to the radii of the circles, QED. Corollary 1. Therefore, since those arcs are the velocities of the bodies and centripetal forces are in the ratio compounded of the duplicate ratio of the velocities directly and of the simple ratio of radii inversely. Corollary 2. And since the periodic times are in the ratio compounded of the ratio of radii directly and the ratio of the velocity inversely, the centripetal forces are in a ratio compounded of the ratio of the radii directly and the duplicated ratio of the periodic time inversely. Corollary 3. Whence, if the periodic times are equal and the velocities therefore as the radii, the centripetal forces will be also as the radii, and the contrary. Corollary 4. If the periodic times and the velocities are both in the subduplicate ratio of the radii, the centripetal forces will be equal among themselves and the contrary. Corollary 5. If the periodic times are as the radii and therefore the velocity is equal, the centripetal forces will be reciprocally as the radii and the contrary. Corollary 6. If the periodic times are in the sesquiplicate ratio of the radii and therefore the velocity is reciprocally in the subduplicate ratio of the radii, the centripetal forces will be in the duplicate ratio of the radii inversely and the contrary. Corollary 7. And universally, if the periodic times is as any power Rn of the radius r, and therefore the velocity reciprocally as the power Rn1 of the radius, the centripetal force will be reciprocally as the power Rn1 of the radius, and the contrary. Corollary 8. The same things are whole concerning the times, the velocities and force by which bodies describe the similar parts of any similar figures that have their centers in the similar position with the same figure, as appear by applying the demonstration of the preceding case to be those. And the application is easy, by only substituting the equable description of areas in the place of equable motion and using the distance of the bodies from the centers instead of the radii. Corollary 9. From the same demonstration, it likewise follows that the arc which the body, uniformly revolving in the circle by means of a given centripetal force, describes in any time in a mean proportional between the diameter of the circle and the space which the same body falling by the same given force would descend through in the same given time. Scholium. The case of the sixth corollary obtains in the celestial bodies, as Sir Christopher Wren, Dr. Hooke, and Dr. Halley have severally observed, and therefore in that follows, I intend to treat more and at large of those things which relate to centripetal force decreasing in the duplicate ratio of the distances from the centers. Moreover, by means of preceding proportions and the corollaries, we may discover the proportions of the centripetal force to any other known force, such as that of gravity. For if a body, by means of its gravity involved in a circle concentric to the earth, its gravity is the centripetal force of that body. But from the distance of heavy bodies, the time of one entry revolution, as well as the arc described in any given time, is given by corollary 9 of this proposition. And by such propositions, Mr. Huygens, and in his excellent book, The Hologio Oscillatorio, has compared the force of gravity with the centrifugal force of revolving bodies. The preceding propositions may be likewise demonstrated after this manner. In any circle, suppose a polygon to be inscribed with many number of sides, and if a body moves with a given velocity along the sides of the polygon is reflected from the circle at the several angular points, the force with which at every reflection is strike the circle will be as its velocity, and therefore the sum of the forces is the given time will be as that velocity at the number of its reflections conjointly, that is, if the basis of the polygon be given as the length described in that given time, and insists of diminution in the ratio of the same length to the radius of the circle. That is, as the square of the length applied to the radius, and therefore the polygon by having its side diminished in infinitum coincides with the circle as the square of the arc described in a given time applied to the radius. This is the centrifugal force with which the body impels the circle, and which the controlling force, wherewith the circle continually repels the body toward the center unequal. 잠시만요. 재채기가 나와가지고. Proposition 5, Problem 1. There being given in any places the velocity with which a body describe a given figure by means of forces directed to some common center to find the center. Let the three light lines PT, TQV, VR touch the figure described in as many points PQR and meet in TMV. On the tangent, erect the perpendicular PAQB-RC reciprocally proportional to the velocities of the body in the points PQR from which the perpendiculars were raised. That is so that PA may be to QB as the velocity in Q to the velocity in P, and QB to RC as the velocity in R to be velocity in Q. So through the ends of APC of the perpendicular draw AD, DBE, EC at right angles meeting in the D and E, and the right line TD, VE produced will meet in S, the center required. for the perpendiculars let far from the center S on the tangent PT, QT are reciprocally as the velocity of bodies in the point P and Q. By corollary 1, prop 1, and therefore by construction as the perpendiculars AP, BQ directly. That is, the perpendicular let far from the point D on the tangents. Whence it is easy to infer that the points S, D, T are in one right line, and by the like argument, the points S, E, V are also in one right line, and therefore the center S is in the point where the right line TD, VE meet, QED. 생각보다 뒤에 양이 많아서 여기까지만 읽고 대학원생이 읽어주는 프린키피아는 끝내도록 하겠습니다.